What's the similarities in humans and mice? That's what Smashing Pumpkins. We're all just rats in a cage. Is that Smashing Pumpkins?
Despite all of your rage,
Is that Smashing Pumpkins? I think.
despite all of your rage at GIFs, you're still just a rat in a cage.
Oh yeah. All right. Good callback. Anyway.
Good callback. See, these memory retrieval exercises I'm doing are actually helping you build a lasting memory of this conversation.
And it's strengthening the visual thing I have of you with James Brown on stage. It's just becoming stronger and stronger by the second. But anyway,
hot tub.
But animal studies work here as well.
Yeah. So let's go to the. So I think I've got great colleagues who I talk to who study memory in mice. And there's some. One of the valuable things in those models is you can study neural circuits in an enormously targeted way, because you could do these genetic studies, for instance, where you can manipulate like particular groups of neurons, and it's just getting more and more targeted to the point where you can actually turn on a particular kind of memory just by activating a particular set of neurons that was active during an experience, right? So there's a lot of conservation of some of these neural circuits across, evolution in mammals, for instance. And then some people would even say that there's genetic mechanisms for learning that are conserved even going back far, far before. But let's go back to the mice and humans question, right? There's a lot of differences. So for one thing, the sensory information is very different. Mice and rats explore the world largely through smelling, olfaction, but they also have vision that's kind of designed to kind of catch death from above. So it's like a very big view of the world. And we move our eyes around in a way that focuses on particular spots in space, where you get very high resolution from a very limited set of spots in space. So that makes us very different in that way. We also have all these other structures as social animals that allow us to respond differently. There's language, there's like, so you name it, there's obviously gobs of differences. Humans aren't just giant rats. There's much more complexity to us. Timescales are very important. So primate brains and human brains are especially good at integrating and holding on to information across longer and longer periods of time, right? And also, finally, it's like our history of training data, so to speak, is very, very different than, a human's world is very different than a wild mouse's world. And a lab mouse's world is extraordinarily impoverished relative to an adult human,
But still, what can you understand by studying mice? I mean, just basic, almost behavioral stuff about memory?
Well, yes, but that's very important, right? So you can understand, for instance, how do neurons talk to each other? Right. That's a really big, big question. Neural computation in and of itself, you think it's the most simple question, right? Not at all. I mean, it's a big, big question. And understanding how two parts of the brain interact, meaning that it's not just one area speaking. It's not like, it's not like Twitter, where one area of the brain's shouting and then another area of the brain's just stuck listening to this crap. It's like they're actually interacting on the millisecond scale, right? How does that happen? And how do you regulate those interactions, these dynamic, interactions? We're still figuring that out, but that's going to be coming largely from model systems that are easier to understand. You can do manipulations like drug manipulations to manipulate circuits and use viruses and so forth and lasers to turn on circuits that you just can't do in humans. So I think there's a lot that can be learned from mice. There's a lot that can be learned from non-human primates. And then there's a lot that you need to learn from humans. And I think, unfortunately, some of the people in the National Institutes of Health think you can learn everything from the mouse. It's like, why study memory in humans when I could study learning in a mouse? And just like, oh my God, I'm going to get my funding from somewhere else. So